Hello, everybody. A warm welcome from Berlin. My name is Fred Klein. I'm a technical sales specialist, so customer-facing role. Today, I have brought with me a topic which is in regards to IBM Runbook Automation. Runbook Automation is part of the IBM Netcool Operations suite since quite some time, and just recently has been added also to the Cloud Pak for Watson AIOps version 3.3. But we are limiting our today's video to the Netcool Operations Insights. For this topic, I have invited Thomas, who is from the development labs. He has a multitude of titles with him, something like team lead and scrum master and all these kind of things. So Thomas, please introduce yourself.
Hi, I'm Thomas Graser, working in the Böblingen lab of IBM. And yeah, as you introduced, that sounds nice. Typically, I am the guy who needs to do the dirt work.
And always one who has to do all the work.
Yeah, right. So, but anyway, I got into that role recently, and it's nice. We have a great team, and it's fun working with them together.
Yeah, Runbook Automation resonates pretty well with our customer base. So this is definitely a topic that is in almost every presentation I do have with my customers and business partners. This topic is new and shiny, and let's have a look into it. So what are we going to talk about? And I guess for that, we do have a graphic. Here it is. What are we talking about? So this is about multi-sources that a single Runbook instance is talking to. So therefore, in the past, we could only talk to one single environment, automate, trigger our runbooks, work with the events from this kind of thing. And that's the topic, that's the problem that we are addressing with the new capability in here. And that's what Thomas is going to take us through. So over to you. Show what we have. I think we have a few slides as well as a demo system in here. And I'm looking forward to your presentation.
All right. Let's start at the bottom of the graphic, showing some systems in a data center. Well, this is what we focus on in our daily life. We have the data center resources running and want to keep them running. So there is monitoring needed on those. If something happens that needs attention by an operator or that needs to be worked on either automatically or manually, there are those probes or other features that allow monitoring, and then events are created based on situations that have been observed. Those situations are then typically listed in a console. On the upper left, you see an event console that shows events from various sources that have been collected. The manual path would be that an operator observes those events and then acts on those that need to be acted on. So there is this arrow in the top where you have a launch in context from the event to a runbook, for instance, and the runbook instructs him or her what is necessary to resolve the situation. And with that, the loop gets closed and the necessary actions are taken by the operator on the resources, on the systems in the data center so that they are working again as expected. For instance, if some storage has been filling up and some offloading was necessary, then this can be done, and following the instructions of the runbook, the situation can be cleared. Now this, what I just described, is a typical manual loop, starting from the resource, having a problem, and an operator acting on that and resolving the problem. This chart shows another loop, which is smaller and does not involve manual interaction. If the events are created, then impact, if it is configured to do so, then impact can read those events and act on them automatically. If the event matches a certain filter, then impact instructs Runbook Automation automatically to run a fully automated runbook, and that fully automated runbook then in turn acts on the resource in the data center, for instance, to clear some space in a file system that was running full. Obviously, those automations have to be prepared in advance. The current limitation is that this loop is restricted to one object server pair. that is attached to the impact system. So moving on to the solution, that would need to introduce some configuration that impact is able to, or that we are able to configure multiple object servers in impact, first of all. And those object servers can reside inside and outside of NOI on the OpenShift cluster. So with that, impact can consume events from much larger set of event sources. And then accordingly, the triggers, which are the configuration items that link event patterns, so essentially the events, to the runbooks, they need, or they can be adjusted and enhanced to not only relate to the original object server, but also you can now select each object server that has been added to the topology, and you can decide within the trigger which of those needs to be addressed by that runbook and which are not addressed. So if you have a very generic event filter that links to a very generic runbook that applies to each and every environment, to each and every object server and the related resources, then you can even say, okay, that trigger applies to all event sources. And you can do that. Or you can restrict it to single event sources or any subset of them. So that would be the configuration part. And then at runtime, impact continues to invoke fully automated runbooks, but now not only based on the events from a single object server, but from multiple object servers as defined within the triggers. And still the operators can manually launch the runbook, both from the existing integration in the NOI itself and also from the web UIs of each of the remote additional object servers that have been added.
This is the overall picture for the whole thing.
Yes, this is the overall picture that shows the final topology. On the lower left, you have the initial topology with the object server that is integrated in NOI. And on the lower right, you have additional object server instances that are completely independent. This is not a geo-redundancy kind of things. These are independent object servers, each with its own infrastructure and potentially also with its own event console. So think of geographically distributed environments. Some of those are residing in different countries, can be, does not have to be. It's up to the topology of the company, how they distribute the data or how they organize their data centers. And with the new infrastructure now, Impact is able to not only retrieve events and act on events from the first set of resources, but also on each of the additional object servers that have been attached. And likewise, Runbook Automation will now address resources and systems in all of those data centers that have been attached. In the previous chart, we had an installation with NOI, including the impact and the web UI within OpenShift. There is an alternative installation option for NOI on OpenShift, which is called hybrid NOI. In that scenario, you have impact and the object server and OMNIbus outside of the OpenShift installation, just like your traditional installation typically looks like. And you have NOI with Runbook Automation on OpenShift installed separately, but the flow works just the same. This new support works for both options, for the full stack NOI and also for hybrid NOI.
This is probably the version that will become most popular, because we do have a large customer base which are using Netcool, as you can see it, with object servers, impact, probes, user interfaces on Linux machines or any other supported platform. And by adding the new stuff, you insert an OpenShift environment and add the Runbook automation capability into that kind of scenario, as well as the other capabilities. For example, if you want to add topology and all the other analytics capabilities, that always requires an OpenShift cluster to be introduced into the existing setup. This is the kind of migration scenario that we're proposing. So I guess this will be the most popular setup. There's not many customers who are installing everything into an OpenShift environment as of now. So this hybrid scenario will be the most popular one.
Yes, exactly. That's what we expect.
Cool, like it.
Okay.
Well, of course, we want to see it.
Yes, so let's move on to the demo. Let's log into the NOI UI and let's have a look at the alerts that exist at this point in time. There is already a runbook that is linked to some of the events. If you look for client status, those events for the NCO primary and NCO backup are linked to a runbook already. And you can view information about that runbook in the side panel, and you could also manually invoke that runbook. Before we go into changing anything, let's have a look into the existing setup and what that runbook looks like, just briefly. When we get there, we have the full set of runbooks, and we just look for that particular runbook that we're interested in. And this runbook contains of 2 automated steps, so it is suitable as a fully automated runbook. The first one would be an HTTP automation to just get some information from a test system, and the second step would be a script automation to write to the standard output the value of the parameter which contains information about the node that the event originated from, that in turn was used to run the runbook. So that will help us to find out where exactly the source originated. Let's have a look at the trigger that links the events to the runbooks. So this has a general section with a description. Now the interesting part would be we have a condition, which is alert group equals client status, and we can test if that is working fine. So that allows to verify that the conditions are properly defined. Then you assign the runbook and you define the parameters. And in this case, the runbook parameter that you have seen before, the event node, is linked to the node attribute from the alert. And then there is also an optional priority. This one is set to the highest possible value. If you have intersecting conditions from different triggers, then you can use the priority to define which ones have to be evaluated in which order. What you also notice is that in this UI, you do not see anything about event sources because there is, by default, there is a single event source. The single event source is the object server that is linked to impact out of the box. And you cannot modify anything in this scenario. So now the interesting part would be how can we add those additional event sources. There is documentation in the NOI 164 documentation how to do that. And here you see in the NOI 164 documentation, you see the instructions how to add additional object server event sources. Also with some preparations that need to be in place before you can actually do it. And then the procedure guides you through the steps to actually get it going. And this is what we want to do now. Let me switch to a test environment. I do have prepared a configuration file that hides the password, so I can just log in to the NOI.
Very kind, so I don't have to mask all these password entries.
All right. So that should help. And we are already in the proper project, which is called NOI in this scenario. And now let's look for the impact part, or the impact server part, not the impact UI, but the impact server part. The part has the name NOI NCI server 0. Now let's log into that part and we change to the directory where the RBA add-on is installed. And now we're already in the right place to run the script that adds the event source. I'll start the script and explain the parameters along the way. The Paris RBA17 would be the name of the new event source. then the credentials, and then the environment, the host name where the object server is running, and also the port. And the second set of parameters is then the potential backup object server, host name, and port. Now this typically takes somewhat between half a minute and a minute. So we are done now already. Okay, it has worked, and we are done with that. So with that, let's switch again and look at the outcome. Now, I did not yet refresh. I logged into Impact before, but I did not yet refresh the UI. So this is what it looks like typically for the Runbook Automation scope. For the Runbook Automation project, you have the Derby database. You can define some data sources here or some data types. And this is the object server that is attached out of the box. All right, so now I refresh the UI and we see our new event source. The RBA17 object server has been added along with the associated data type. And if we have a look at the data items, we expect to see events from that RBA17 system, from the remote object server.
So this piece works.
Yes, that's fine. And when you go in there, you see the data that we have added in the as parameters to the script. Okay, so that's on the data model side. On the services side, there is also a new entry that has been added. It is this our Paris RBA17 event reader, which is stopped at the beginning by default, and that's fine. It will be started automatically as soon as the first trigger is created that applies to this new event source. Okay. So now let's just go ahead and do right that. So let's switch again to the Runbook UI and modify our existing trigger to include that new event source. Maybe let me step back 1 second and have a look at the web UI of that remote system. The object server was running on RBA17 and the web UI that is associated with it is running on RBA18. So this is the web UI. And for this, you see the client status event is not linked to a runbook at this time. And we want to change that. We want to make sure that all client status events also in this environment get updated with runbook information so that operators can launch the runbook, or even better, that our fully automated runbook takes care of the event whenever a new event is created of that type. Let's change that trigger. We still have the trigger details, but now all of a sudden we have a new section here, which is called Trigger Alert Sources. That shows up automatically as soon as multiple event sources are defined within Impact.
That's something I was about to ask. So we didn't refresh the user interface.
Yes, that's correct. It's not necessary to actively refresh it. Of course, the Runbook side must get aware of the changed or the added event source. There is some caching on the Runbook side, so it might take 2 minutes or a little more until that data are refreshed. But then there is no further need to restart something or actively refresh.
Makes it easier to use.
Yes, definitely. Like definitely. Out of the box, this trigger that we have created before is applied or continues to apply to the alert source RBA object server, which was the default. But now we have the option to also add the Paris RBA17 object server. And if we do that, you'll get an indication, okay, that will apply to both of them. If you decide that this trigger that you're editing here should apply to each and every event source, even for future event sources that are not even known yet, you can also switch off that toggle, and then this trigger will be applied to all available event sources. Okay, Okay, so there is complete flexibility. Yeah, let's limit it to those two, just in case we add like Rome and we want to keep control on which event sources that trigger should be applied to. So we actively select the two of them, but everything else can stay the same. We have the same conditions, we have the same runbook linked, and we have the same priority. So let's just go ahead and save it. And now the interesting part will be if that event, once it gets recreated, will be associated with the runbook information from the runbook that we have just entered. With that, so that will take some time until that OMNIbus self-monitoring event is recreated. So while we're waiting for that, Fred, do you have a question on the solution?
Oh, this looks really great. I really love it because the ease of use, which makes it really nice, because you just have to look into the user interface and the backend already decides, there's a new object server, and just let it use it. This is really a cool feature. I like it.
Yes, thanks. While we're waiting on that self-monitoring event to be recreated, maybe let's just go ahead and do the same on the other side so that we can see that the fully automated runbook will be invoked not only for events from the new event source, but also from the existing event source. And let's see. All right. The client status has been recreated and it is now at this point in time set for automatic execution, and we have that runbook related information added. And we also see, if we look into the details, that this links to our NOI on OCP environment. And with that, let's have a look here onto the execution tab within the Runbooks experience. And we see, oh yes, there have been quite a few new invocations, fully automated invocations, 3 in total, and they have been created just recently. Now let's have a look into the details. All right, here we have the output of the first automation. That was this HTTP automation I was talking about, and that looks okay, was successful. And here we see the event has been created on OMNIbus Service Netcool, which is the name of our remote Paris system. So you see here the node is typically set to OMNIbus Service Netcool in that environment. So this matches, and is just what we expect. So this was the proof that from this event, the fully automated runbook in our NOI environment has been invoked. And if we look at the other two, we have OMNIbus Service Netcool again. And here we have the NOI NCO backup as the source of the event. And we have the NOI primary as the source of the third fully automated execution of the runbook. So with that, we have seen that now with the added event source for our Paris environment, we now have extended the reach of both the runbooks and also impact along the way, have extended the reach to include the Paris data center. Yeah, and I think with that, we are happy and have the loop closed. Maybe what we have seen right now was the closed loop for the fully automated runbooks. Now maybe let's have another look at the manual integration. So going back to the alert viewer within NOI and to the runbook tab, we have seen that the fully automated runbook has been run, but we can also decide for whatever reason to run it again manually. And that's what we can do now. We can, if necessary, modify the parameter, but we just take the parameter from the event that's been pre-filled, start the runbook, run the first step, indicating that it was still running. And similarly, let's run the second step. Again, you have that indicator that the automation is still working. We got that second part of the fully automated runbook also finished successfully. That's excellent. We did the launch in context and it worked fine.
That's the feedback for the administrator.
Yes, exactly. That might be helpful for the administrator. If an operator notices something was not working as expected, or some step didn't really look perfect to the operator can give feedback, and administrators can now look at the feedback and improve those runbooks that need improvement, both because they are executed very often, and also if they got bad ratings by operators, then this is typically an indicator that something needs to be done about them. And we could do the same from the other event, but now the more interesting part would be moving back to the UI for the events on the Paris remote data center. We can do the same as we have done before for the alerts on the primary and secondary NOI. We can also do a launch. As you can see here in this huge list, this is a development environment with all kinds of variations. But this particular launch tool has been created to launch from the Paris web UI right back into the NOI on OCP, where the runbook is residing. And guess what? The properties from the event have been passed on with the launch in context information, and we can right away start the runbook also manually in that environment, run it, essentially repeat what the fully automated runbook has been doing before. So that one worked as well. And this concludes not only having a closed loop for the fully automated runbooks, but at the same time having a closed loop for the manual handling of events and acting on the events using a runbook and affecting the resources in the data center. All right.
Thank you, Thomas. That was really a great demonstration of the new capability that we have introduced in Netcool Operations version 1.6.4. One question remains: can we add that to older installations? For example, if we upgrade the object server, the impact server, and Runbook Automation, is that something that we can deploy piece by piece, or is this something we can only apply if we deploy the whole Netcool Operations inside version 1.6.4?
Well, it can be added step by step, as we have discussed before. If we have a environment with a hybrid NOI, then you would just upgrade the existing deployment of your Netcool impact server to fixed-pack version 23 or later. This has been out for some time, so that will probably already, I would assume that you have done that already, also to get security fixes and everything to stay in sync with the infrastructure. And so with that established and a few preparations that have been documented, you're ready to go with the existing deployment and put the NOI hybrid deployment on the side with Runbook Automation inside that NOI deployment. So yes, that can be done, and the existing environment can be leveraged to contain and to supply that new feature.
Great. Thank you very much, Thomas. So we started
welcome.
today with a single sourced environment, just one object server, impact server, Runbook Automation. And then you added a secondary target and you introduced that to the backend system, that there is a potential secondary target. And then you introduced it into the runbooks, that they're automatically used, as well as you showed how to add that into the manual runbook execution. I really like that. So cool feature. And just to name it, this was a customer request brought to us, and here's the solution. So this is really cool. So looking forward to see many customer installations. And with that, we are at the end of today's video. So thank you very much, Thomas, for the preparation of this really cool demonstration, the slides and the demo. Thank you to the audience for your time you spent in watching the video. and see you another time in another video. Thank you.
Thanks for having me, and have fun with the new feature.